I'm going to talk to you about what we're doing on Friday's lesson. I'm going to show you some of the methods you need to use in it. You're going to need to watch this video a couple of times to pick up those methods. I'm going to set you that for homework. But to give you a bit of an idea of what we're doing on Monday, I'm going to explain it to you first. So, Monday, I meant Friday. On Friday, I want to give you a task which you should find challenging. There will be another member of staff from a different school coming to see us, and she will kind of see how you tackle the problems that I give you. The other thing that we're looking at is different teaching styles. So, and this is a different teaching style. I'm going to ask you to watch this video a couple of times. I'm going to give you a chance to watch it in Wednesday's lesson. I'm going to ask you to watch it at home. I'm going to ask you to make kind of one side page of notes in your homework book on the things that I show you, so that you can use them as soon as you get into my lesson on Friday. The idea then is for my lesson to be about you tackling problems and me helping you tackle those problems. Okay, so in Friday's lesson, I'm going to introduce you to a Year 10 topic. You're in Year 9, you're set 1. I'm going to introduce you to a challenging topic, which hopefully by the end of it you'll find a lot easier. But it's called, it involves something called surds. So the topic is this, called manipulating surds. And you will have seen surds before. You've been doing Pythagoras with me. So you have got to the point in a Pythagoras problem where you've been dealing with and manipulating square roots. Okay, and surds involves the square root operation. As an example, the square root of 100 is not a surd, because the 100 is a square number. So if you take the square root of 100, you get 10. Okay. A surd is where you have something like this. So you would have the square root of 5. Now, the square root of 5 is not a square number, so if you take a square root, you get a decimal. You get a decimal that never repeats or recurs. So what you actually have is an irrational number. Okay, so as a mathematician, you kind of want to keep root 5. If you keep it written as root 5, then you lose no accuracy. And the longer you can maintain writing it in that form through a calculation, you are essentially losing no accuracy. So if you can collect other terms that have got root 5 in together, and it might be that at the end you do the square root operation in order to give yourself a distance or a measurement, but whilst you leave it like that, then you're maintaining accuracy. So the first rule that I'm going to give you is this. If you've got a question like this, the square root of 2 times the square root of 3, you can simplify that. Actually, I'm going to write it underneath. You can write it as the square root of 2 times 3, okay, which equals the square root of 6. So root 2 times root 3, written in its simplest form, is root 6. That's the first rule. The second rule that I'm going to show you is slightly different. I'll give you another example. I want you to manipulate and write in its simplest form the square root of 12. Now, that's not in its simplest form, and the reason it's not in its simplest form, I'll show you. We aim to kind of write a surd as a kind of a single surd, but we might multiply it by an integer value, and you'll see that we do that with this. Now, we are aiming to minimise the number that appears under the square root sign, essentially. So it's a case of spotting this to begin with. You could rewrite this as follows. So you can rewrite square root of 12 as the square root of 4 times 3, which equals the square root of 4 times the square root of 3. The square root of 4 is 2, so you write it as 2 root 3. We've minimised the number under the square root sign. We've got an integer coefficient, if you like, which we got by pulling out a factor of 12, which is a square number, and that factor is 4. And that's essentially what you're looking at. You're looking at kind of pulling out a factor which is a square number. The question is root 2 times root 14 in its simplest form. Okay, so you're going to use the first rule, which means I can rewrite that. The first rule says that I can rewrite that as the square root of 2 times 14. 2 times 14 is 28. I can write that as root 28. The second rule says, can I pull out a factor of 28? That is a square number. And the last question that we did, the factor that we pulled out was 4. In this case, it's going to be the same. So if I divide 28 by 4, I get 7. So I can rewrite that as root 4, root 7. And I know what the square root of 4 is. It's 2. So the square root of 28 is the same as 2 root 7. And what I didn't say in the other two questions, which I would say, is if you have your calculator, put this in. Okay, put in square root of 28, see what you get. Put in root 2 times root 14, see what you get. You'll find that Casio calculators are very good at giving you the answer as surds. Okay, so you should be able to check. You should get an idea that you're getting the answer right. Change them to decimals and see what they come out as. You know, you should have an estimate of what the square root of 28 is. You know what the square root of 25 is. You know what the square root of 36 is, so you know roughly where that sits. The fourth rule, the fourth kind of technique that I want you to practice is this. So the example question is this: 2 root 3 times 4 root 5. Now, how can I rewrite that? To start with, I could write it as 2 times root 3 times 4 times root 5, and that means that I can do I can change the order of multiplication. So I can do 2 times 4. 2 times 4 is 8, and I can write the square root as 3 times 5 is 15. So I can write it as 8 root 15, which is fine. You need to just be careful that you have minimised the number under the square root sign. So in this case it's 15. Can I pull out 4 as a factor? No, I can't pull out 4 as a factor. So the next one that I'd be looking at to pull out as a factor would be 9. I'm looking at pulling out my square numbers as factors. That is its simplified form. If I was to write this, the square root of 100 times the square root of 100, and I'm also going to make an apology because I noticed when I watched the videos back that I wrote the square root of 100 is 10. Okay, part of the reason that we keep numbers as surds is because you know, as soon as you take a square root, then there's 2 possible solutions. The square root of 100 is positive 10 or negative 10. But the square root of 100 times the square root of 100, you know, let's choose one of those solutions. If the square root of 100 is 10, you times it by the square root of 100, which is also 10, you get 100. So the square root of a number times by the square root of the same number is that number without the square root. Okay, that's quite important. So if I was to have a question like this and I wanted to write it in its simplest form, I'd use that. So if I wanted to find the square root of 72 in its simplest form, to be honest with you, rather than trying to pull out a square number, and you might spot quite a big square number factor that comes out of 72, the other way to do it is to look at the prime factorisation of 72. So if I do 72, it's even, so I'll pull out a 2, I get 36. Now at that point, you might already see that I've got a square factor. Pull out a 2, 18, pull out a 2, 9, 3, and 3. So the prime factorisation is, my pen is running out, which is a bit of a shame. 72 is, well, I could write the square root. Actually, I'm going straight for that. The square root of 72, I could write it as root 2 times root 2 times root 2 times root 3 times root 3. Okay, those two things combine to make 2. So I've got 2 times root 2, and these two combine to make 3. So I've got 2 times root 2 times 3, which equals 6 root 2. Okay, that's it. Okay, so to round off the video, it's longer than I would have liked actually. Hopefully you will have seen it once in my lesson. You will watch it once at home and make a few, just a page, just skim, skim over it, make a page of notes so that you can just tackle some questions in my lesson. The kind of importance of that is kind of that that style of teaching is that you spend a bit of time out of the classroom listening to me talking, watching me show you some examples, and then you actually spend the time with me supporting you to do those examples, which is more effective use of my time. The other things that I need to say is that I'd like your feedback. So in the lesson we're going to spend about 40 minutes on maths work, and then I'm going to use the end of the lesson to kind of give you a short survey to see what you felt about the method of teaching. The level of challenge is quite important to me. This is a topic where you wouldn't usually see this until year 10, probably near the end of year 10. So I want to see how you cope with it. And other than that, if you don't like watching videos, I apologise. I don't like being in videos, so it's a bigger thing for me. And lastly, I said the square root of 100 is 10, and I should have said the square root of 100 is plus, positive or negative 10. If you tell other members of the maths department about that, they might shoot me, so I'd appreciate if you didn't do that. But thanks for your patience, thanks for listening, and I'll see you on Friday. Thank you.